everyone, thank you so much for joining me again today. So today, grade 12s, we are looking at exam paper 1 revision. Now generally in these types of revision sessions, what we do is we look at the big topics. So we look at things like calculus and functions because that accounts for about 50% of exam paper 1. And it's great to do that, but what I want to do in today's session is something a little bit different. I want to look at the two sections that learners battle with the most in exam paper 1. So it's not necessarily the sections with the biggest marks, but obviously when you add everything up together, it all counts. So the two sections that learners battle with the most, if we look at the exam paper 1 from 2020, the two sections are financial maths and probability. And I'm sure just when you heard me say it, you already knew that those were the two sections. Financial maths and probability tends to be the two sections that learners struggle with the most. So obviously we cannot go through every single thing in this short time, but what I would like to do is to go through some of the big concepts from financial maths and from probability, and then clear up some of the misunderstandings that many learners have. Okay, so let's get started straight away with financial maths. Okay, so just reminding you of some of the formulae that you use when you work with financial maths. There's the simple interest formula, which is your accumulated amount is equal to your principal into 1 plus I times n. So let's just remind ourselves that A is the accumulated amount. I'm not going to write the whole word. P is the principal amount, or the initial amount invested or borrowed or whatever the case might be. I is your interest rate divided by 100, and N is your time. Okay, now when we look at simple interest, generally you will always be given questions where your interest and the number of, or N, are in yearly periods, so they're in the same units. But sometimes it's not always the case, but generally it does happen. So you will be given something like, say, N is 18 months, and then your interest is obviously yearly because we're dealing with simple interest. So what you're expected to do, if you're given an example where you've got 18 months and it's a simple interest question, is just change 18 months to 1.5 years. How do you change from months to years? You simply take your months and divide by the number of months in a year. So 18 divided by 12 will give you 1.5. Now, simple interest, we know that that's dealing with a simple rate of growth. So there's a plus sign that we use in our formula. Then we get simple depreciation, and this we use, it's also called straight line depreciation, to show that the value of an asset is decreasing. And we notice the big difference between the two formulas, there's a minus now between the two signs. In compound interest, this is where we're dealing with growth, and you've got the formula that you all should be familiar with. Remember that if you are trying to get to n here, which is a power, you have to use logs. So how do we use logs? Remember what I've always said is a log is a different way to write an exponent. So if I have, for example, 3 squared is equal to 9, and I want to convert that to log form, it's my exponent is equal to log of the number to base 3. So the base of the exponent becomes the base of the log. So basically I've rewritten the exponent 2 using logs. When we look at compound depreciation, we notice that the sign in the middle changes to a minus to denote that the value of the asset is decreasing. Remember, when you deal with compound interest, we need to keep the rate of interest per time unit and the time period in the same month. So if you are working in months, then you remember to divide I by 12 and times N by 12. Okay, in reducing balance depreciation, which was that second formula we looked at there, compound depreciation results in higher depreciation in the earlier lives or earlier years of ownership of an asset. And why is that? That's basically because compound depreciation is based on a reducing balance. So it's based on the asset's previous balance. And when you work out compound depreciation, every period, the depreciation will be a percentage of the reduced value. So we take into account that the value of the asset has reduced in the previous period. So the value of the asset depreciates by smaller amounts every time. Now, one of the big topics that you do in grade 12 is annuities, and an annuity is basically a regular sum of money that is paid regularly. So it might be into a savings account or into a pension fund where you're saving, say, 600 Rand every month. Okay, so that would be an annuity. We also look at future value annuities and present value annuities. We break those two things up and say that generally when we're looking at investments, we deal with future values, and when we're looking at loans, we deal with present values. So let's talk about future value annuities. The formula will be given to you on the formula sheet. As always, if you haven't been practicing with this formula, you won't know what to put where, so make sure you've done enough questions and you've practiced a lot. X is your monthly payment, F, or sometimes we write FV for future value, represents your amount. 1 plus I is your interest rate, N is your period. And remember to keep those two the same. So both must be accounting for monthly compounding or whatever it is, quarterly or whatever the case might be. All right. So in future value annuities, we get regular payments are being made into a savings account or an investment fund, and it's accumulated to a certain amount at the end of the time period. This formula, this is very important, this formula calculates what we call an ordinary annuity. So in an ordinary annuity, you're basically making payments at the end of every period. So at the end of every month or at the end of every year. So that's called an ordinary annuity. But sometimes in a question, you will see that they'll say payment starts immediately or payment starts at the beginning of the period. When those kind of words are used, then you have to adjust the formula, and it makes sense to adjust the formula because look at what's happening. So let's look at a timeline here, and we've got time 0, time 1, time 2, and time 3. So in an ordinary annuity, your payment will start at the end of the first time period. So it will normally start at time 1, where we make X amount, okay? With what we call an annuity due, the payments are made straight away. So payments start now. Now what that means is, let's just say these 1, 2, 3s represent months. Now, if the payments are starting now, you will get interest of 30 days, right, in that first month. So if your payments start right now, you need to account for that interest that you've accumulated over 30 days. So that's almost like it's extra interest that you're getting compared to an ordinary annuity. So you have to adjust the formula. So what do? So to calculate the future value of an annuity, you multiply your result, which is this formula here, by 1 plus I to reflect that extra interest rate. Payments usually start immediately instead of one period into the future. So your question will say, payments are starting immediately, as I said, or payments are made at the beginning of the period. So all you do is you take your formula, which is, let's just clear the screen so we can see the formula nicely. You take that formula, which is for an ordinary annuity, and you times it by 1 plus I when you have an annuity due. Okay, similarly for present values, but we'll talk about that just now. Now, when we deal with sinking funds, this is a type of a savings account almost where generally what a business does is they know that they're going to have to replace a very expensive piece of equipment or vehicle in the future. So what they start doing, they know, okay, well, when we get to 20 years' time, I cannot afford as a business to have 500,000 Rand to buy a brand new piece of machinery. So what they do is they start saving now. So they start saving and saving and saving until they have enough saved to replace that piece of machinery when they need to replace it. This is what we call a sinking fund. So it's almost like anticipating that you're going to have this debt in the future. So you start making sure that when you get to that point in time, you have the money available and you are not going to be in a lot of debt at that point in time. So let's just go over it. We know that all assets depreciate due to age. So businesses will often set aside money for replacing outdated equipment or old vehicles into what we call a sinking fund. They make regular deposits and sometimes lump sums, and often the formula you will use when you're dealing with sinking funds is the future value formula. And they put money in there so that enough money will have accumulated by the time a new machine or vehicle needs to be purchased. Okay, so sinking funds often tie in with lots of different things happening in a question. They will say to you, you need to work out how much of money they need to have in the sinking fund to replace a certain item, and then you would have to use, depending on what the question says, but you will generally have to use the future value formula and the compound interest formula, depending on what they need you to work out in a sinking fund question. Present value annuities, very important concept that you learn in grade 12. The present value of a series of payments is given by the formula P, or PV, is equal to X, which is your monthly payment. And you notice that the formula is changed. It's not 1 plus, it's 1 minus 1 plus I to the negative n, to reflect the fact that payments are coming backwards. So we're basically finding out what's happening at a certain point in time. So our payments are going in that direction. Okay. N still the same as always, that's your time period, and I is your interest rate, and make sure that these two correspond. Okay. So with present values, we have regular or equal installments are made, generally to pay back a loan or a bond on a house or a loan on a car over a given period of time. The reducing balance of the loan is usually charged on compound interest at a certain rate, okay, which is obviously given to you in your question. All right, guys, so that's some of the main things that you learn in grade 12, and things that you need to be aware of. Like I mentioned, your annuity dues, you need to times by 1 plus I if payments start immediately or if they are made at the beginning of each of your time periods. And hopefully I've gone through some of the type of things that generally confuse learners in exam situations, and hopefully this has helped you as well. All right, so when we come back, we're going to look at another section that learners often struggle with in exams and definitely score the lowest marks in as a section, and that is probability. Hi guys, and welcome back. Today we are looking at the sections that generally in Paper 1 give learners the most problems, and those sections are financial maths, which we've just covered, and now we're going to look at probability. So what I really want to look at in probability is not the Venn diagrams and the tree diagrams, but a concept that a lot of learners struggle with the most, and that's the counting principle. Okay, so what does the fundamental counting principle say? Let's have a look at that. It says that if there are n possible outcomes for event A and m possible outcomes for event B, then the total possible number of outcomes for both events is n times n. The order in which the experiments are done does not affect the total number of possible outcomes. Okay, so that all sounds very mathematical. Let's put it into an example and see what it means. Say, for example, you had 2 shirts and you've got 3 pants. And you want to see, well, how many possible ways can I combine that and make different outfits? So you've got 2 shirts, 3 pants. So you have n of your shirts, so 2, and then m of your pants, so 3. So what are the total number of possible different outfits? It's 2 times 3. There are 6 different outfits that you can combine. Okay, so that's basically just a simplified answer of what the fundamental counting principle is all about. So you've got n number of items, m number of items, and altogether you've got n times n possibilities. The order doesn't matter, so it doesn't matter if I say 3 pants times 2 shirts or 2 shirts times 3 pants. It's commutative, which means the order doesn't matter, you'll get the same answer. All right. So this is where we use the fundamental counting principle a lot, because drawing a tree diagram, it's possible, yes, but for a small number of events. But as soon as those events become really big, then the total number of outcomes becomes really impossible to work with. So when drawing a tree diagram will just become impractical. So think about if you toss a coin twice, then you have 4 possible outcomes. That's easy enough to reflect using a tree diagram. Okay, quick little tree diagram. What about when this becomes tossing the coin 3 times, and then your tree diagram now gives you 8 different outcomes, right? All right. And what if we then say, well, toss the coin 4 times, 5 times, 6 times? Those numbers start becoming really, really big. So 2 to the power of 6, for example, is 64. Drawing a tree diagram to reflect 64 branches is really impractical. Okay, so that's a simple idea of why drawing a tree diagram is impractical and why we should use the counting principle. So let's look at an example. Say you have the letters A, B, C, D, and you want to discover the number of ways to arrange them in 3-letter patterns if repetition is allowed. Now this is where it's very, very important to read your question. You always need to make sure when you are counting the number of ways that something can happen, you need to make sure if repetition is allowed or it's not allowed. That's the first thing you should always do in a counting question. Is repetition allowed? Is it not allowed? Here it's allowed. So that means that A, B, A, D, C, A, and B, 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 where all the B's are repeated, are perfectly fine. Those are considered different arrangements. Now, they say you will find that there are 64 ways to get to arrange these letters A, B, C, D in 3-letter patterns. Why? How did I get 64? This is because for the first letter, so let's just draw little spaces here. So for the first letter, how many letters do I have to choose from? 1, 2, 3, 4. So there's 4 options for the first letter. For the second letter, again, there are 4 options because repetition is repetition is allowed, so letters can be repeated. And for the third letter, again, you have 4 possibilities to choose from. So therefore, 4 times 4 times 4, 4 cubed, which is 64. So you can choose any of the 4 available letters for the second, the first, and for the final letter of the pattern. So therefore, all you would need to do is multiply the number of available choices to give you your total number of outcomes. So, boiling this down to a formula, when you have n objects to choose from and you choose from them r times, then the total number of possibilities is basically n times n times n repeated r times. So n to the power of r. So going back to our example about the letters, 4 times 4 times 4, we had 4 objects to choose from and we were choosing from them 3 times. So here n would be 4 and r is 3. So therefore the total number of possibilities is 4 cubed, 4 times 4, which is 6 times 4, which is 64. So this is why I said you need to read your question carefully. So when you are not allowed to repeat letters or numbers or whatever, colors or whatever the question says, without repetition, outcomes without repetition, then the total number of possible arrangements is different and it actually becomes less. This is when we use this idea called factorials. Okay, so the total number of possible arrangements of n different objects is n times n minus 1 times n minus 2 all the way to 3 times 2 times 1, which gives us n factorial. And we know that 0 factorial is actually 1. That's just a definition. So what we're saying here is, say we look at that letter example again. So there were 4 letters to choose from, but now you're not allowed to repeat the pattern. So each time you have less letters to choose from. So we still had that. We still have letter arrangements of 3. But the first time I choose letters, I've got 4 to choose from. The second time, because I've now used the letter in first place, I only have 3 to choose from. And then the third time, because I've used 2 letters in position 1 and 2, I've only got 2 left. So 4 times 3 times 2, 4 times 3 is 12, 12 times 2 is 24. Do you see, guys, how your number of possibilities is reduced when you are not allowed to repeat letters or numbers or objects? Okay, do you see? We went from 64 to 24 if repetition is not allowed. Okay, so you've got to be very careful with what the question says. So let's look at this example, and this was from the DBE exam, and this is the 2020 paper, paper 1. This question says, in a certain country, 10-digit telephone numbers with the following format were introduced. So basically they're saying you've got this kind of number where it's got an area code followed by an exchange code and then a number. So the area code was allowed to have 3 digits, exchange code 3 digits, and the number has 4 digits. So altogether, if you count it, 3, 6, 10, 10-digit telephone number. So for example, you could have your area code being 901. Your exchange code is the number 544, and then the number 1230. So that would be an example. 901-544-1230 is an example of a 10-digit telephone number. All right. So they say, how many possible 10-digit telephone numbers can be formed? So there's no restriction. The question hasn't said anything about repetition not being allowed. So therefore, what do I have? For each and every one, if you count from 0 to 9, there are 10 digits. So for the area code, I've got 10 times 10 times 10. So for those 3 digits, I could use any of the 10 digits there, any 10 there, and any 10 there. Similarly, for the exchange code, 10 times 10 times 10. And for the number, it's 10 times 10 times 10 times, it needs to be 4 of them. And how many have I done? 1, 2, 3, we need 1 more. Okay, so if you multiply those, and remember guys, also look at what I'm doing, I'm multiplying, I'm not adding. This, when you are trying to work out the number of possibilities, we don't add things together, because here there is no repetition, they haven't given us anything, because there is repetition, they haven't given us any restriction on our numbers, we're simply going to multiply all of those digits together, so I get 10 to the power of 10. Okay, now they say certain restrictions are being placed on the groups of digit. The area codes must be 3 digits, okay, so 1, 2, 3. The first digit cannot be 0 or 1. So I used to have 10 numbers to choose from, but now I'm not allowed to use 0 or 1 in first place. So therefore, 10 minus 2 gives me 8 possible digits that I can choose for the first place. Okay, there's no restriction on those 2 numbers there in the area code, so this will still be 10 and 10. They go on to say the exchange code must be 3 digits. Okay, so we get 3 places there. And the first and second digits cannot be 0 or 1. So now, both in position 1 and 2, we cannot have 0 or 1. So there's 8 choices there. There's no restriction on the third digit. Finally, the number itself must be 4 digits, which we know, 1, 2, 3, 4. And the first digit has to be 0 or 1. So the only possibilities here are 0 or 1 and 0 or 1. And then there's no restriction here. So let's talk about these two. 0, 1, 0, 1 here. That means you've only got 2 options for position 1, 2 options for position 2, and then position 3 and 4 can be 10 times 10. So altogether, how many valid 10-digit numbers could be formed given those restrictions? So this is what we said we're going to do. It's going to be 8 times 10 times 10, and then times 8 times 10 times 10, times 8 times 10, and then we're going to say 2 times 2 times 10 times 10. All right, so I've worked all of that out for you, and this is what we get. The number of valid digits, there we go, 8 times 10 times 10, 2 times 8 times 10, and then 2 times 10 times 10 times 10. All right. All right, so here I've made a little error. I see here I've said the first 2 digits must be 0, 1, but they said it's only the first digit that must be 0, 1. So that's why it's so important to also read your question carefully. It's so easy to make a careless mistake like that. So the first one only has to be 0, 1. So there's a restriction only on that first number. So this would be 2 times 10 times 10 times 10. All right, so if we multiply all of that together, you get 1024 times 10 to the power of 9. Let's quickly look at the last question. They said determine the probability that any number would be a valid telephone number. So you randomly choose a number. How do we know it's going to be a valid number based on these restrictions now? So all you do is you say, well, let's look at the probability, which is going to be the number of possible ways that we can get a valid 10-digit number given those restrictions, and then we divide by the total possible number of digits that can be formed, and that's 10 to the power of 10, which we worked out in part A. If you divide those two, you end up with a probability of 10.24%. Okay, so the main thing I wanted to get across here is just read your question carefully, make sure you understand if there's repetition allowed or repetition not allowed, and that will help you to really go a long way in getting the right answer in counting questions. Thank you so much for joining me. Until next time, take care.